Okay, let's take a look at graphing the other four trig functions. So we have sine and cosine taken care of, hopefully. So now we need to take care of tangent, cotangent, secant, cosecant. Now, tangent is going to be significantly different than sine and cosine. It's going to go from negative pi over 2 to positive pi over 2, which means it now has a period of just pi, not 2 pi. Now, you have these asymptotes right here. And the graph is going to go right through 0, 0. And it's going to slide up from left to right. So it looks like that. Now, cotangent, on the other hand, is going to have an asymptote at 0 and an asymptote at pi. And it's going to slide down at pi over 2. And so it's going to look broadly like this. So this one is tan x. This one is cotan x. Now, in shape they're very similar, but you'll notice this one is centered around the x-axis. This one is not at all centered around the x-axis. It's centered around pi over 2. This one also is flipped over, so you need to make sure we pay attention to those. Now, another way to think about this is, if I have a tangent of x, well, at 0, it's going to be an opposite of 0, an adjacent of 1, a hypotenuse of 1. So the tangent at 0 is going to be 0. But a tangent at 90 is going to be opposite over adjacent. So you have 1, 1, 0, 1 over 0. That's going to be undefined. And so it makes sense that at pi over 2 it's going to be undefined. Same thing's going to happen when you're down here. It's going to be 1, negative 1, or I'm sorry, 1 over here, negative 1 over here, and 0 at the top. So your tangent down at negative 90 is also going to be undefined. So when you talk, by the way, about tan inverse of x is only going to be defined from negative pi over 2 to positive pi over 2. And I put equals, there should not be equal to, because there's asymptotes there. So negative 2 to positive pi over 2, just exactly like sine inverse. Okay, so make sure you have that. So this looks like this. Cotangent, we go the other way. Well, that would be adjacent over opposite. Adjacent over opposite makes sense if we're going to come up at 0. At 0 degrees, adjacent over opposite is 1 over 0, so it's going to be undefined. However, when you come around to 90, adjacent over opposite, 0 over 1, so it's 0. So it makes quite a bit of sense. Now, that's tangent, that's cotangent. If I were to have something like 2 plus tangent of x, well, now what you would simply do is you would take your tangent, and instead of having negative pi over 2, positive pi over 2, and crossing at 0, it's now going to cross at 2. By the way, those should be equal. I drew them slightly out of scale. So you move it up 2. If we were to put a negative in front of it, 2 minus tan x, well, now it would slide down from the top and still go through 2. If we were to put some sort of number in front of tangent, we can change the amplitude of tangent. That's not that challenging. The problem is when you change the amplitude of tangent, it's actually hard to plot. Unlike sine or cosine, that goes up to a certain amount or down to a certain amount, with tangent, when you change the amplitude, much like x squared, if you were to simply take the two ends and pull on them, it would simply look more straight. So it would still be curved, but it would be a more gentle curve. Versus if I had a 1/2 out in front of it. If I had a 1/2 out in front of it, then you end up with 2 plus 1/2 tan x. That would be something where it comes down makes a very sharp bend, and then turns around and goes down again. So amplitude, the best you can do is kind of show me on tangent and cotangent. I'm not going to be too concerned with amplitude because it's very, very hard to do by hand. So don't worry too much about that. Now, we can, of course, shift it. If I take 2 plus tan of x minus pi over 2. Okay, well, it's plus, so it's going to rise from left to right. Up, excuse me. I kept drawing them moving this way, but whether it is the red, it should be going up. The plus 1/2, it should also, even though it's tighter, be going up. The only one that should be sliding down is the one with the negative in it. Excuse me. So, if we draw a fresh set of axes, in this case we have 2 plus tan x minus pi over 2. So, instead of negative pi over 2, positive pi over 2, we're going to, instead of start here, we're going to start here, but I still have to go a full distance, so I'm going to end over here at pi. Now, we're going to still move up 2, so over pi over 2, up 1, 2, and we're going to move just like that. There we go. And so not that terribly challenging. We can also change the frequency. Frequency would be something as follows. If I have tan of 2x, well, first things first, we always, of course, have to draw the standard. So we have tan of 2x, so standard tangent looks like this. Tan of 2x, well, if I have frequency equals 2 pi over period, that works for sine and cosine because the period of sine and cosine is 2 pi. But for tangent cotangent, the period is pi, so it's frequency equals pi over period, or therefore period equals pi over frequency in the same relationship. So in this case, the frequency is 2, so period equals pi divided by 2. So now I have to do the same thing in half as much space. So instead of having an entire pi to do it, I only have pi over 2. But because it's centered at 0, it's not going to just shrink from one side or the other. It's going to shrink from both sides, meaning that I'm going to go from negative pi over 2 to positive pi over 2. I'm sorry, pi over 4 and positive pi over 4. So now the whole thing has to happen within this range. And there we go. So it shrinks. If, on the other hand, we were to have tangent of 1/3 pi, or 1/3 x, that means period is going to equal pi over 1/3, which is the same thing as saying pi times 3 over 1, which is pi over 3. Which is 3 pi. So if I need to go 3 pi, that means instead of negative pi over 2, positive pi over 2, I need to go 1.5 pi's each way. So I end up with 3 pi over 2 this way, and negative 3 pi over 2 this way. And so now it gets super duper duper wide because it has to go a total of 3 pi. So that's the way frequency, vertical shifting, horizontal shifting work for tangent cotangent. Stay tuned for the next clip for secant and cosecant.